The curve C is defined by the parametric equation where x is given in terms of the parameter t, 3t squared plus 2, and y is given as 6t minus 1. Okay, and you are told that the t is greater than or equal to 1, 6. The line n is the normal to the curve C at this point, okay, where x coordinate is 14 and the y coordinate is 11. And we need to find the Cartesian equation of n, which means the Cartesian equation of the normal. And then we got to convert the equation in this form, okay, ax plus by plus c is equal to c, where a, b and c are integers that needs to be determined. In other words, you need to find the values of a, b and c, and in order to get the 5 marks. So y is equals to 6t minus 1, which you can see here, and x is equals to 3t squared plus 2. I have just copied that down. So let us differentiate y with respect to t. Okay, why do I want to do that? Because we need to find the equation of the normal. So of course, before we can find the equation of the normal, we need to find the gradient of the tangent first. So if I differentiate y with respect to t, okay, of course I won't get dy dx, I would get dy dt. So 6t minus 1, if I differentiate, 6t will become just 6. And x, if I differentiate it with respect to t, it's going to become dx dt, and that should of course be 2 times 3, which is 6, 6t to the power of 6t to the power of 1, which is 6t. And now let's find what is the dy dx. Dy dx is of course equals to dy dt divided by dx dt, which is simply going to be dy dt is a 6, and we're going to divide that by 6t, right? So that is the value of your dy dx, and of course if you cancel the 6 and the 6, you get 1 over t. That is your dy dx in terms of the parameter t. Now let's go and find out what is the value of t that we need to substitute. If let's say this is the curve, okay, if let's say the curve looks like that, and we go to this point, which is called 14, 11, because that is the point of our concern. That's where we need to find the normal. So 14, 11, and this is x coordinate. 14 is x coordinate and 11 is the y coordinate. And if you look at the x and y coordinate in terms of the parameter is linear, whereas the x coordinate is quadratic. So it's better for us to use the linear the parametric equation. And so let's equate the 60 minus 1 to be 11, so that we know exactly at what value of t this point comes about, right? So let us equate 60 minus 1 to 11. And of course, when we solve this, minus 1 if you throw over to the other side become plus 1. 11 plus 1 is going to become 12. And 12 if you divide by 6, it would be giving you t is equals to 2. So now we know that t is equals to 2. Now we can find the dy dx, right? So because it's going to be just simply 1 over 2. And what would the dy dx would give you? Dy dx is of course going to give you the gradient of the normal. So we know that if I were to, gradient of the tangent. We know that if let's say at this point 14, 11, if we were to draw a tangent line, the gradient of the tangent line would be equals to half. Now we know that the normal is supposed to be perpendicular to the tangent. So it would be easy for you to find what is the gradient of the normal. So let's draw a line that's 90 degree to it. And of course, if two lines are perpendicular to each other, the product of their gradients should be equals to -1. So of course, if this gradient is a half times the -2 is what that's going to give you -1. Therefore, the gradient of the normal based on the gradient of the tangent, the gradient of the normal should be equal to -2. So we know that the m normal is equals to, m means the gradient of the normal is equals to -2. Now how should the equation of a straight line look like? Of course it should be of the form y equal to mx plus c. So where the m is the gradient, so since we already know the gradient of the normal is -2, I'm just replacing the gradient with the -2. So we get a y equals to -2x plus c. We still do not know what is the value of the y-intercept of the straight line. So in order to find the value of c, we need to know one set of coordinate that the line passes through. And if you look back at the normal line, we know that it also passes through the 14, 11. After all, we are finding the normal at this point. So we could take the x and y coordinate from this, and we can substitute or replace the y and the x with 14 and 11. And we will substitute that, and that would give us what is the value of c. So y coordinate I replace it with 11 and my x coordinate replace it with 14. So negative 2 times 14 is negative 28. If I throw it to the left, it become positive 28. 28 plus 11 is going to give us the value of c, which is equals to 39. Now we got the y-intercept as 39. We can put it back into this step. So the equation of the normal would be y equals to minus 2x plus 39. But of course we need to express it in this form. That means we just need to leave the constant on the right side. The terms with x and y, we have to bring it to the left. So let's bring the minus 2x to the left. So it's going to become plus 2x plus y is equals to 39. And now we can see it is of the form ax plus by equal to c. So by just comparing, we can see that the a is a 2 and the b is a 1 and c is 39. There we have the equation of the normal in Cartesian form. Let's now move on to part 2, which says find the area enclosed by C, which is a curve, N, which is the normal, as well as the x-axis. Okay. Now, before we do that, let us eliminate the parameter t. Okay. If you were to eliminate the parameter t, how would I do that? Okay. T is equals to y plus a 1, okay, and then divided by 6. So that would give us the value of t, and you can take that t in terms of y and substitute into the expression for x. Okay, there is only a t square here, so if you replace the t here with y plus 1 over 6, and then you square it and you simplify and do all the manipulations and simplification of algebraic expression, you should finally be able to derive 1/12 of y square plus 2y plus 25. What you can notice about this is it is also a parabola, but with its axis along horizontal axis. So if we were to sketch it, okay, you can also use a graphic calculator and sketch it out to see. So we would be getting a graph that looks like this, and of course it will go this way, which is if there is negative. But there is no negative term involved here because 1411 is over here. So this is x, okay, is equals to 1/12 of y square plus 2y plus 25. And of course we need to find what is the x-intercept. So when you want to find what is the x-intercept, of course we're going to replace the y with a 0. And of course if I replace the y with a 0, so these two terms will disappear, leaving you only a 25 and a 12. So it would become 25 over 12. X-intercept at y equal to 0, and if we substitute that, so y the value of x would become 25 over 12. So we know that this x-intercept is 25 over 12. Now let's draw back the normal. Just now we already found the equation of the normal is minus 2x plus 39, right? So that's the normal, and this point is where the 1411 was. So the x coordinate is 14 and the y coordinate is 11, right? And we can see that we are told to find the area enclosed by the curve, which is this, and the normal, which is this purple line, and as well as the x-axis, which is this horizontal line here. So we can see that there is a triangle and there is a area below the curve. So we need to find out, if I want to use the area of a triangle, I need to use half base times height. Height I already have, which is 11 units, but the base I do not have. So I need to find out what is this x-intercept of the normal line. So for this we can replace the y with a 0, and we can find out what is the value of x. So at x-intercept y equal to 0. So if I replace this with 0, we're going to have 2x equals to 39, and the value of your x would be simply 39 over 2. So there we have the x-intercept. Now let's get ready to find the area of this triangle, and of course the formula for area for triangle is half base times height. So how much is the base? It would be 39 over 2 minus 14. So this length, this little length here will be the base. So let me write 39 over 2 minus 14. And then the height of this triangle would of course be equals to 11 units. So times by 11. And if you simplify and press in your calculator and get the value, it should give you 30 and 1/4 of unit square. So that is the area of this little piece of triangle here. Now let's go and find what's the area of this curve section, okay, of the graph. So area below the curve, we know that we need to integrate from 25 over 12, right up to 14, right, because this particular yellow region is only between this value of x to this value of x. And of course the height would be y, and the thickness, we're going to take small thickness of dx. So y integrate with respect to x, taken from 25/12 to 14 would give you this area. Right, but we need to either change the express y in terms of x in order to perform the integration, and of course if you look at this is parametric, right? So it would be better if we can change everything here in terms of the parameter t itself. That would make life a lot easier. So I'm going to replace my y in terms of its parameter 60 minus 1. So I have just replaced the y in terms of t. And how about dx? Okay, we have x in terms of t, but we don't have dx in terms of t. To do that, we can actually differentiate x with respect to t to find what is the dx. So x, if it is equals to 3t squared plus 2, so if we differentiate this with respect to t, okay, 2 times 3 is going to be 6, then 6t to the power of 1, which is 6t. So that's the value of dx dt, but what we need is only dx. So let's cross multiply the dt in order to express dx in terms of t. So dx would be simply be equals to 60 times dt, so 60 dt. So I have replaced the dx with 60 dt. Now these limits were the limits for x, right? So we need to change them in terms of the limits for t. So we know how x and t are related. So this is how the relationship is. So let us now do this, okay? When x is equals to 25 or 14, okay? So I'm going to replace the x here with 14, and then the 14 should be equals to 3t squared plus 2. So if 3t squared plus 2 is equals to 14, okay, if I were to express that, then your 3t square value would be 14 minus 2, that would have been a 12. 12 if you divide by 3, that would have given you a 4, and square root the 4, it should give you plus 2 or minus 2. Okay, but I have rejected the minus 2 and I have just kept the t is equals to 2. The reason for that is, if t is equals to 2 and we substitute 6 times 2, which is 12, minus 1, which is 11. So of course we are talking about this point here. But if minus 2 is substituted into the y coordinate, it should give you minus 2 times 6, which is minus 12. Minus 12 minus 1 should be minus 13. So we know that if this parabola was extended here, so there would be one more point where the y coordinate would be minus 13. But of course that's not the value that we want to integrate. And that's the reason why t equals to negative 2 is rejected. So when x was a 14, the t would have been 2. So we replace the 14 with a 2 because we need to integrate with respect to t. Now we're going to do similarly for the lower limit, which is 25/12. So when x is equals to 25/12, let's equate that to 3t squared plus 2 and look for the values of t. So when we do the same way, okay, so we take 25/12 minus a 2 and then divide by 3 and square root the answer. We should be getting 1 out of 36, or t is equals to negative 1 out of 6. Of course the negative 1 out of 6 is rejected, because if you substitute that in here, the y coordinate becomes negative, which is not the graph, right? So it's only the positive side of the graph is what we have. So t equals to 1/6 is what is kept. So in place of 25/12, now I'm going to replace it with the limit of 1/6, because that's the limit of dt. So now we have it in terms of t. Okay, we can integrate it with respect to t, and all the limits are all changed in terms of the limits for the t. So let us now evaluate the area. Okay, this section of the area. So 60 times 60, we can change it to into 36t squared. 1 times 60 is going to become 60. So there we have it. Now it's readily integrable. So 36t to the power of 2 is going to become 36t to the power of 3 over 3, and 36 if you divide by 3, it would simply become 12t cubed, and 6t squared over 2 would become 3t squared. So there we have the integral, and then let's keep the limits 2, okay, the upper limit, and the lower limit is 1/6. Now all that is left of us to do is to substitute the limits. So when t is equals to 2, so t cube is going to become 8 times 12 minus 3 times, okay, 2 squared, and then we can just evaluate that. Then later subtract away the lower limit substituted, which is 1/6 cube and 1/6 square here, and work out the overall answer. and of course due to the insufficiency of space here for explanation or to show you the complete working, so I have jump steps and I have just put in 84 and 1 out of 36 unit square, and that is this yellow area which I have shaded here for you. This is the area below the curve. Now the question asks, what is the area enclosed by this, right? So now we need to add up this area plus the area of the triangle. So the total area would be area of the triangle, which is 30 and 1/4 unit, plus the area below the curve, which is another 84 and 1/36 of a unit. And if we add them together, it should give us 114 5/18 unit square. So that should be the total area under the curve and under the normal line as well as the x-axis. Let us now go for the part 3. The part 3 says the curve C and the line N, which is the normal, are both transformed by a two-way stretch, okay, by a scale factor of 2 in the x direction and of course by a scale factor of 3 in the y direction to form a second curve D, okay, and the line M. So the question is asking what happens to the area enclosed by D, M and x-axis. D is the transformed curve. So of course if you stretch along the x-axis by a factor of 2, so the area is going to double, and if you stretch along the y-axis by a factor of 3, okay, it's going to triple, right? So all that you need to do is a new area would be the old area just now we calculated between the curve, the normal and the x-axis, which was 114 and 5/18 unit. And since we are stretching along the x-axis by 2 units, so let's just simply multiply by 2, and then along the y-axis by a scale factor of 3, and therefore the area will triple along the y-axis. So if we multiply them together, and it should give us a total answer of 685 and 2/3 unit square. So that would be the new area enclosed by D, M and the x-axis, and that should give you 1 mark. Let's look at the part B, which says find the Cartesian equation of D when we perform these transformations, okay, with a two-way stretch by a scale factor of 2 in the x direction and a scale factor of 3 in the y direction. And of course we have already calculated the parametric equation earlier, right? So it was x is equals to 112 y square plus 2y plus 25, and when we have a stretch factor of 2 in the x direction, so what we could do is to replace the x with a x over 2 and simplify the expression. So you're told that stretch by a scale factor of 2 in the x direction, so I'm going to just replace the x with okay, x over 2. So of course the x becomes replaced with the x over 2, so we have this equation, which is basically the equation after you perform a stretch with a scale factor of 2 along the x direction. Here there is a 2, here there is a 12. Let's eliminate the 2 by multiplying both sides of the expression by a 2. So 1 over 12 is going to turn into a 1 over 6. So we get the equation x equals to 16 y squared plus 2y plus 25 after you perform the stretch along the x direction. Now we need to go for stretch along the y direction by a scale factor of 3. Of course this time we're going to replace the y with y over 3. So let's replace the y with a y over 3, and of course each of this is going to now turn into a y over 3, and x is equals to 16. The y I have replaced with the y over 3 square, and this y also I am replacing it with the y over 3 plus a 25, and we can simplify that. Okay, it will be y squared over 3 squared, that's a 9, and then after that we can expand out with the 6. Okay, so or we can just factorize out, so we will end up getting x equals to 1 over 54 times y square plus 6y plus 225, and this would be the Cartesian equation for the curve D. So that should give us another 2 marks.